Welcome back to my YouTube channel, guys. In this video, I'll be explaining discriminant. Discriminant, right? Discriminant. What actually discriminant actually explains? It helps us like it's a portion of a equation. It helps us determine the nature of roots of that equation, right? That is, help us. It shows us the nature of the root. That is, my previous video I explained what roots are. So it explains what the roots will look like, right? So discriminants can be for all equations. That is, can be for quadratic. Like I said in my previous video, can be for quadratic, can be for cubic equation, even quadratic equation, and so on. So but in this video I'm going to be focusing on quadratic equation, but as you get higher and higher it gets more complex. So but for the level I'm going to be focusing on the quadratic equation. This is the general, let me just divide this place into two. This is the general formula for the quadratic formula. We have ax squared plus bx plus c equals 0, right? Then this is the quadratic formula. That is, if you want to solve for x, you have minus b plus or minus square root of b squared minus 4ac to a. So the area under the square root determines the root of the equation. Determines the root of the equation. Whereby that is d is equals to b squared 4ac. Because if you look at it, you either have from this equation you can either get a plus or minus from this. I'm going to be explaining further in the equation. So this determines the root of the equation. Like I said, this is just for quadratic. So now to determine, when you have this, without the determine the root of the equation can, like I said in my previous video, quadratic equation only have two roots. Quadratic have two roots, and I split further for that one. So they will have two answers. That's the meaning, right? Then after solving it, you have two answers. Then to know the nature of those two roots, so is either either real. Yeah, I'm going to be explaining that further, or equal, or imaginary. That is, or sometimes it's also called no root per se. So real is anything. It can be, as long as the answer is a number, can be 2, it can be a decimal 2.3, can be a root 2, any number, as long as real numbers are vast. So it can be a fraction, as long you can, is that a number or negative as well, whatever number it is. Equal is, like I said, that is, but these are uh two real numbers. And let me just write two real numbers. So there'll be two different numbers. Why equal is that? What is also, they are also real numbers, but they have to be equal. Either 2 and 2, minus 8 and minus 5 and minus 5. I'll be showing further in the calculation. Why imaginary root is anything that gives us anything like square root of, let's say, minus 5. There's no way to go further this. In maths, you can literally just write you can just write you can write sometimes this can be described as this. Sorry, this can be described as, okay, this, we have one, we have, this can be described as, So whenever I see I, we have square root of minus 1. Because naturally you can't take the square root of a minus 1. Right? So whenever you have a minus under a square root, you have an imaginary root. Right? So going further, so to know when our our root is two two real numbers, or let's say two real distinct numbers, d has to be greater than 0. That is, the discriminant has to be greater than 0. That is, for example, if you have x squared minus 5x plus 6 equals to 0, I want to know if this equation, the root, that is the answer, will be real and distinct. Right? Real and distinct, like I said, there are three: real and distinct, equal, or imaginary. Real and distinct, I'll show you an example. So you have to use that's greater than 0. So when you solve using this, you have b squared minus 4ac, right? Then b, let's check this out, equals to 1 here is from using this. A is what? 1, b is equals to minus 5, then c is equals to 6 equals to 0. So if you substitute this into this, you have d equals to minus 5 all square, sorry, minus 4, a is 1, c is 6. How do I put this? So you have d equals to 25 minus 24. D is equals to 1. So since d is greater than 0, the roots of the equation will be, you have two real roots. Sometimes you can see that two real and distinct, because the second one I'm saying is equal, so distinct roots, right? So for example, the answers could be, let's say 5 and 4, let's say minus 8 and 3.2, could be root 5 and minus root 5, like I said, example. So no, sorry, okay, root 5 minus root 5, yes, you can have that, as long as they are not equal. Yeah. So, and you can also represent this in a graph. So when you have something like this for the real and distinct, whereby is equals to 0, right? Equals to 0, so it's crossing the 0 line. So when we have a to be, that is our, is positive, that is facing up, since a is positive, I say that means these are two distinct points. So the graph looks like this. Or for example, if our x square is negative, we have, if x square is positive, but when x square is negative, we have something like this. So it's crossing the line on 2 points. It's crossing the 0 line that is equals to at 2 distinct points. Okay, to continue, to know when our equation will have equal roots. Now d has to be equals to 0. Right? For example, we have x squared minus 4x minus 4. Like I did in the previous video, d is, like in previous example, minus 4ac, right? So from this equation, a is 1, b is minus 4, c is minus 4, and d is equals to minus 4 square minus 4a minus 4, right? So you have d equals to 16 minus 16. So d is equals to 0. Right. So you can say this equation have two equal roots. Two equal roots. And also they're also real numbers. Real numbers. Why this? There are two distinct. So if you have an answer of 3, you also have an answer of 3, answer of 5, root 5, you have answer of 5, or 8.2, you have an answer of 8.2 here as well. So I have to represent this in the graph. So when you have something like this, crossing it at 0, could have something like this, touching it at only 1 point. This is for when our x square is positive. Let's do for when x square is negative for that case. But for this particular solution, is positive. So at this point will be the number. For example, if our number is 3 and if our answer was 3 and 3, this point will be 3. So this represents a quadratic equation that has equal roots. Then we'll be going to when our equation, when the roots are imaginary, or normally called no roots, right? So that is when d is less than 0. So for an example, you have x squared plus x plus 1 equals to 0, right? So like we have doing, first with d is b squared minus 4. Sorry, this is equals to. So a in this equation is a is equals to 1, b is equals to 1, c equals to 1. Okay, this equals to 0 again. So d is equals to 1 square minus 4 was our a, 1, c is what? 1. So you have d equals to 1 square, 1 square is 1, then minus 4, you have d equals to minus 3. So d is minus 3 now. So the root of this quadratic equation will be imaginary. That is let's write imaginary or no roots. As you could have something like minus 16 minus 8, just basically square it with the negative, and most of them are, you can be represented as I, that is square root of minus 1 is I, right? So you can have something like minus 3 plus 2i, or minus 3 minus 2i. So these are example of imaginary answers in your quadratic equation. So and this can be represented just like this. For positive, as long as the your x is positive, so instead of it will be touching the x, because it's equals to 0. If you notice it, because it's equals to 0, that's our constant trait. So because it's equals to 0, it's not be touching the 0. So this is for positive x square, or if you have a negative x square, your answer will be something like this. Just that the idea is just to show that it won't just be touching the x, as but for the equal roots, it's just touching it at a point, right? And also in the two real as well distinct roots, it's touching that two different points. That's if you plot the quadratic graph. Thank you.